All right, good afternoon, everyone. My name is Chris Donaghy. I'm the Chief Executive Officer of Applied Energetics. It's always fun being the last presentation of the day because I'm standing between you and happy hour, so we will try to get through this as quickly as we can. First of all, I would point out that these slides that we're going to go through, they are available on our website. So I'm going to try to get through them as quickly as I can and hopefully leave time for Q&A. First, the obligatory safe harbor statement. And with this slide, I can generally tell pretty much the entire Applied Energetics story. So this is our vision statement, directed energy anywhere. First thing to understand is every laser that you read about in the media, whether it's deployed on a Navy surface ship, a UK surface ship, or by the Israelis, all of those lasers are experimental or prototype. There is no such thing in the US Defense Department as a program of record where the government is buying lasers on a regular programmatic basis. They've all been experiments or prototypes. So this vision statement is actually a pretty ambitious vision statement because it's basically saying that we expect to be the company that is going to develop a laser capability that you can deploy on any platform you want, whether it's a mobile platform or a deployed site overseas, or even fixed sites such as domestic military bases or power plants or the border or prisons. In order for that to be accomplished, you have to check 3 boxes. First of all, you have to have a widely proliferating threat that is vulnerable to directed energy weapon systems. Small drones check that box. The second thing you have to do is you have to build a laser that can obviously deliver effects that take advantage of those vulnerabilities. Lasers check that box, our laser as well as the traditional lasers that you're used to hearing about. The third box that has not yet been checked, however, is size, weight, and power. And you'll see later in the presentation a comparison of the size of our laser relative to what is trying to be used today against drone threats. And you'll see that those systems today tend to be very large, they're cumbersome, they're slow, and they slow you down as you're trying to move. So until someone figures out how to check the size, weight, and power box, this vision statement would be very difficult to be realized. And we think that we have the technology to be able to check that third box, and hopefully you'll be convinced of that by the end of the presentation. We're going to do that by focusing on a particular class of laser called an ultra-short pulse laser. I'll talk more about what that means later on and what the benefits are of that particular class of laser and why we think it is best suited to achieving that vision statement that we just went over. Structure of the presentation, it's an investor presentation, it's typical. What's the problem? What's the solution? Why are we the guys to deliver that solution? And ultimately, how big is the market and how big is the opportunity for our company going forward? We don't need to dwell on the threat. You see it all the time. If you go on LinkedIn and follow certain accounts, there are videos that show up daily of the use of small drones as a weapon system in Ukraine. It has become the primary effector that the Ukrainians are using against the Russians, and it's also a primary effector that the Russians are using against the Ukrainians. And you can see it's an exponential increase. And most people believe that drone warfare is here to stay. What that means, however, is that as drones continue to augment humans in the battlefield, sensors related to those drones are going to saturate the battlefield, and that is what we intend to go after, those sensors. The reason why, if you look at small drones are used for 2 purposes. They're used for surveillance. You launch the drone, you fly it over the hill, you see if there's a bad guy on the other side of the hill. If there is, you launch a second drone, a one-way kamikaze drone that has an explosive attached to it. You fly it over the hill. It looks for the bad guy, and when it sees the bad guy, you fly the explosive into that particular platform, and you try to take it out. So those cameras are extremely vulnerable to the effects of ultra-short pulse lasers in particular, which we're going to talk about with a few slides and some example photographs of what the attack actually looks like here in a couple of slides. This is just another way of talking about the vision statement. The laser was invented in 1960. The US military has been wanting to field lasers onto the battlefield since 1960. There are still no lasers widely fielded on the battlefield now 65 years later. And again, it's not because Lockheed Martin can't build a really cool high-power laser. Their 300,000 watt laser, delivers some really cool effects, but that laser exists in 3 shipping containers. 1 shipping container for the laser, 1 shipping container for the power supply, and 1 shipping container for the cooling system. That is not a directed energy anywhere kind of system. That is, this can do really cool things, but I have no place to put this thing, and by the way, it's a sitting duck because you can't move it. So again, you have to check that final box. You have to check the size, weight, and power box if you're going to see the inflection point of the technology adoption curve typically associated with new capabilities. You have to solve the size, weight, and power problem. We think we are very well positioned to be the company that causes the bend in that adoption curve for directed energy system used by military customers. And again, we're going to do that through the use of a particular class of laser called an ultra-short pulse laser. Ultra-short pulse laser, what does that mean? It means we take a relatively small amount of energy and we slice it up into small pieces every second, and then we compress each one of those slices to fractions of a fraction of a fraction of a second. Very, very small time duration for each one of these pulses. And as we compress that pulse, the peak energy of that system goes through the roof. The design power for the laser that we are building for a counter-drone application is 20 billion watts of peak power per pulse. And 20 billion watts of peak power into the optic of one of those drone cameras is pretty devastating. It's a near instantaneous kill of the camera system. We are also building a family of lasers that operate at different wavelengths, 5 different lasers that we're concurrently building to address visible, near-infrared, short-wave infrared, mid-wave infrared, and long-wave infrared sensors. If we can match the laser wavelength to the wavelength of the camera, there is no countermeasure. You cannot stop this laser from disrupting or destroying the sensor associated with that particular camera. We have also taken an architectural approach. We're using as much commercial telecom fiber optic cable as we can because fiber optic cable is relatively easily to ruggedize. It gets a little bit more exotic as you get to the higher power amplifiers, but the objective is to be as end-to-end fiber optic oriented as we possibly can be. That makes it easier to manufacture and it makes it more ruggedizable. So when you look at the effects, at long distances, what you're going to do is you're going to dazzle the sensor. It's going to create a bright white spot that the camera can't image anything else in the field of view, but when I turn the laser off, you get your image back. If we increase the energy or the target gets closer, you start to do damage to that sensor, but eventually you cross some threshold and you will actually cause catastrophic to the sensor and it will fail to operate, which is what you see in this final slide here, or this final picture here. That final picture is from a demonstration video that we built in the middle of April. That uses a 25 million watt peak power pulse, and it destroyed the camera within the first 1/30th of a second of the laser hitting the sensor there. If you're interested in learning more about this, I can show you the actual demonstration video. I just can't show it in a public video, in a public forum. But more importantly, we're also addressing the size, weight, and power problem that I described earlier. The objective of this system is to be about the size of 2 shoeboxes, weigh less than 60 pounds, and when you plug this thing into a wall, it uses about the same amount of energy as your garage door opener. Yet the peak power of that laser, again, is 20 billion watts. So you're getting 20 billion watts of peak power out of something that you can plug into a wall. That is a very, very different approach than what you see other companies doing with laser weapons on the battlefield. What you see on the right side here is a 10,000 watt laser built by a company called Blue Halo. The main thing to understand is up at the top. That system is 60 times the size of our laser. And when you want to deploy this system, you have to put it on a trailer, and the military is not big on pulling trailers around their tactical vehicles. Again, it slows them down. If you want to use the laser, you got to stop, you got to stabilize it, you have to make sure it's charged, you have to drag a generator along with you to charge the batteries. It's not easy to do. You have a question?
Where did the fiber optic piece come into it?
The fiber optics are all inside that gray box.
Okay.
So the architecture is, I don't know the exact number, it's several meters of different types of fiber that are stitched together, and each step along the way, you're amplifying the energy of the laser. But if you looked inside that, what you would see is just spools, different spools of fiber optic cable that make up the laser.
Are you in the field of operation now?
We are not.
How close are you?
I'll get to that.
Is there any degradation in distance or?
So there is. It's like a normal laser. You know, normal lasers, they spread out as they propagate. So what we do is we build a model. So all we can say is that this is capable of achieving a tactical range. And a tactical range means it goes beyond 1 kilometer. We can't talk about what the actual range of the system is, but think 1 kilometer or beyond. So what we do.
You can't talk about it because you're in the DoD contract, or?
Yes, the specific performance parameters and operating parameters of the laser are they're classified. Yep. I call this my Where's Waldo chart. So this is a 60 kilowatt laser built by Lockheed Martin. It's called the High Energy Laser Mobile Test Truck. 60 kilowatt laser. For comparison purposes, this is an at-scale representation of what our tripod-mounted system would look like sitting next to the Lockheed Martin system. You can buy dozens of our lasers for the price that it costs you to build that Lockheed Martin laser, and you can distribute them. So we would become the outer layer of a drone defense system. There's going to be multiple different types of technologies that you use to counter drone swarms in particular. We are potentially the outside layer because you can buy so many of our systems on a relative basis. You might still want that Lockheed Martin laser, but what you want to do is you want our laser to fire first. So when the drone swarm comes over the horizon, there's going to be an AI that is the command and control system that says, shoot this one first, shoot this one second, shoot this one third, and we would be blinding the drones as they're coming in. So we are killing the mission of the drone. We're not technically killing the drone. That's where the high energy guy comes in. So you blind the drones first, and then that buys time for the continuous wave laser to go actually kill the system if that's your objective. But from a military perspective, if you can kill the mission, you have, in essence, neutralized the enemy. So killing the mission is just as valuable as killing the system. Again, the advantage is that we do it in less than a second, and even these higher energy lasers take multiple seconds to cause destructive damage to the drone itself. We've been doing this for a long time. Our chief scientist ran Lockheed Martin's laser programs back in the 90s. He left in early 2000, and he started building an ultra-short pulse laser system to demonstrate the effects of what you can do with an ultra-short pulse laser. However, the laser that he built, it was a pretty amazing piece of equipment. You can see in this middle column, he built a 5 terawatt peak power laser, 5 trillion watts of peak power. You put 5 trillion watts onto a piece of sensitive electronics, it's going to cause some pretty nasty effects. The problem is that that laser was never going to be fieldable. Sometimes it took 4 PhDs just to turn the thing on. So you were never going to be able to ruggedize that laser and put it into a DoD platform. So he went back to the drawing board and in 2018 relaunched with this new architecture based on fiber optic approaches, specifically going after size, weight, and power as the problem and ruggedizability of the system. 26 patents, 11 patent applications that are held under government secrecy orders. That means those patents haven't even been published because the US government doesn't want those patents made public, so that it gives you a roadmap on how to do some of this stuff. We have 8 additional patents pending. Those numbers are probably going to change here pretty soon. We received notification that one of the applications has been approved. And then we've been doing work under what we consider mission-relevant contracts, and that is a contract for the Marine Corps to demonstrate counter-ISR, counter-electro-optic, the ability to take out camera sensors. For the Army, it is a contract to do an infrared countermeasure laser. It's not dazzle the heat seeker of a surface-to-air missile, it's drill a hole through the heat seeker of a surface-to-air missile, so you don't have to maintain a laser lock. You actually destroy the seeker, and the missile will lose lock and veer off from whatever its target is. For the Navy, that's a more sensitive application, but the Navy has big platforms. They have things that they are very concerned about attacking those big platforms. That third contract is building a laser capability to address that particular mission. We do this out of the University of Arizona Tech Park. We have a dedicated clean room laser lab on the first floor of this building, and then down the hall, down that blue hallway that you see, we have another 6,000 square foot facility where we have built an indoor laser test range that we call our battle lab, where we do effects testing. And by the middle of this year, we'll be doing on-demand demonstrations of this capability to qualified visitors, whether you're a DoD customer or a partner that we're interested in talking to, a politician. And we do think that at some point we'll be able to get to the point where we could do a demonstration for investors as well, as long as you're a US citizen. I became the CEO in November of 2024. Prior to that, I had been the CFO since August of 2022. The catalyst for the change is the motion from the research laboratory into hardware. Converting the science into something that we can take into a room and turn it on for warfighters and demonstrate the capability in a more mobile and more space-efficient footprint. We're not at the objective footprint just yet, but I do think that by the end of this year, we will have our first prototype system of that tripod laser that would have more of the form factor that you would want to see if you were going to deploy this on a military platform.
Are all your applications military or are they civilian applications?
I'll talk about that on a future slide as well. So again, the thing that I have heard consistently for the last several years is, okay, I believe that you can kill sensors. When can I come see it? I can't bring a warfighter into the R&D lab. If you saw the laser on the R&D table, you wouldn't even know what you were looking at. It's a bunch of piles of fiber optic spaghetti kind of spread out everywhere, and you wouldn't know if this thing was going to be a product in 6 months or 20 years. So we had to get to a point where we have something that is more compact, where you're not staring at the fiber optic spaghetti, but you're more closely focusing on the effects that are being delivered. So the highest priority of the company is to be able to do on-demand demonstrations when a customer or partner asks for it. When they call me and say, I really want to come see this demo that I've heard about, I can say, be here at 10 o'clock in the morning and we'll do the demonstration for you. The demonstration is ultimately going to be 3 drones operating separately in a static configuration. They won't be flying around, but 3 drones operating with our laser, and when you hit the go button, it's whack, 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 dead, dead, dead in less than 5 seconds. When we can show customers and partners an ability to neutralize drones, 3 drones in less than 5 seconds, that's going to be a pretty significant inflection point for the company in terms of the momentum that we will generate with our customers. The second thing that we've done is we've acquired a platform that adds the things that we don't currently do. We have been focused on the laser. We have not been focused on the command and control system. We have not been focused on the acquisition and tracking platform. We've not been focused on the gimbal. Frankly, those are all things I can buy. That's what we're buying from Cord. I could buy it from Raytheon. There's lots of people that I can buy acquisition and tracking capability. We don't need to do a demonstration against a flying drone because all the people we're going to show, they already have systems that can do that type of thing. What we need to show them is an effector that can produce results at a sub-second scale that would demonstrate value onto the battlefield.
So you don't do any of the visualization? Yeah, like the drones floating around, you have to be told where it is through, let's say, course.
Correct.
And then you can direct your laser to it.
Correct. Well,
And is it independent of day, night?
Yeah, in fact, the Cord system has both a very high-end mid-wave infrared camera as well as daylight cameras and a LiDAR for ranging. So they have that capability already on board. And then the next step is we move into engineering. So we're positioning now to be able to hire an engineering team. We've already identified a lead for that team. That guy intends to bring 2 or 3 of his engineers with him to start to move the company toward production toward the end of the year. And then the last aspect of this, again, is getting to that standalone prototype system, again, by the end of the year. So just a little bit more detail on that. So again, the laser itself is in a rack-mounted configuration. So it's take the thing that was on the R&D lab, put it into 2 small drawers, and slide those drawers into a half rack. Again, not the target footprint, but significantly smaller and something that I can show a warfighter that makes more sense to them. And again, we're doing this in an indoor laboratory. This is an indoor test range, so this is about 90 feet by 30 feet. By the middle of the year, we intend to have 5 different lasers operating in this indoor battle lab across multiple wavelengths. So if a customer wants to bring their own sensor in and see, hey, do you have a laser that can take out this sensor? We have the laser that matches the wavelength of the sensor to be able to do the demonstration. Yes.
So do you do this on land? Do you do it on ships? Do you do it, is it application? Is that versatile?
It is. So again, the objective here is to build a laser that can be deployed on any platform that you want, ranging from Navy ships to aircraft to the smallest land-based vehicles, including things like the Polaris M-Razor, which is the side-by-side 4x4 vehicles that you see running around the Arizona desert where our headquarters is. Again, because this is a very low power draw, our laser is intended to be able to plug into the prime power of any platform you want to deploy it on, including these smaller vehicles.
Can you do this on a drone?
Oh, that's a good question. Someday. So if you were, we've had this conversation, you can shrink the laser down to a small enough level that you could conceivably deploy it onto a drone, but you're going to have to be relatively close range. That's not going to be a tactical range system. That's going to be something that you're getting in close, you blind the drone, and then something comes in from the other side.
How close is the close range?
My guess is probably 20 to 50 feet. Again, you're talking about significantly reducing the power of the system. You'll still get millions of watts of peak power, but you're not going to be doing it at the same repetition rate that you might get out of the full power system.
Any plans with DoD?
Oh, yes. Yeah, so let's see what's next here. Okay, so again, we've had these 3 contracts that we have had. They are pure demonstration contracts. Here's a little bit of R&D dollars to prove to us that you can kill a drone camera with an ultra-short pulse laser. The funding that we have received is not sufficient to build the entire laser system. We are doing that on our own. So how many of you saw the 60-minute special on Sunday night with Palmer Luckey, right? So we are taking the same approach that Anduril is taking. We do not want to be a defense contractor. We want to be a defense product company. So we are using privately raised capital to accelerate the development of these capabilities as fast as we can. Where we can get government contracts in this early stage, we'll take it, but this is about building the capability as fast as we can and taking it to market as a commercial product. So eventually, yes, when we get to a certain technology readiness level, think level 5, TRL 5 or so, we will be able to tap into much deeper wells of capital that the DoD is providing to accelerate this kind of technology to the field faster. Again, the company has been focused, however, on the R&D of the basic concepts of what we're trying to do here. And we have received some government funding for that, but that wasn't really the point. We never intended for the government to fund the whole development of this system, because frankly, when you take government money to develop the capability completely, you're capping your margins in the future when they go to buy the system. We're developing it as a commercial product that will allow us to sell the product at commercial margins.
Everything manufactured in the U.S.?
We're not even in manufacturing yet. So what I can tell you is the reason why that lower left side of the chart exists is that we have run into supply chain issues. There are certain countries we're not allowed to buy certain components from. There are certain components that we can't find a good domestic source for quality components, so we've had to do some vertical integration to be able to start building certain components on our own in order to ensure consistency, quality, and actual availability. Yeah, we intend for it to be as much domestically sourced as possible.
What do you think you could get to that point in the U.S.?
So it'll depend on the relative maturity of the system when we get there. So an end-to-end fiber optic laser The final amplifier is going to require some very specific fiber types that are very hard to find right now. We have had to design one of those fibers ourselves. We got to find somebody who can build it for us. There are organizations, certainly in the United States, that can do that, but sometimes they're hard to get to. So in that particular case, we expect it to be a domestic source, but we just don't have that. We don't have that capability yet. So the first demonstrators of this system are not going to use that architecture. They're going to use a different architecture, but ultimately we intend for it to be domestically produced and sourced.
What's your long-term plans, or mid-term to long-term plans?
So I'll get there with the next slide. So this is how big is the market? The market's potentially huge, $30 billion for directed energy in 2030. What I would suggest to you, however, is you're not going to see that kind of spending for directed energy systems until someone solves the size, weight, and power problem. So we think if this is going to be a $30 billion industry someday, you have to solve the size, weight, and power problem. We're taking that approach head on. We expect to be a significant player in that $30 billion market in the next 10 years or so. So what does this look like?
You got that $95 billion market there, right?
Okay, so that actually I should have come back to your question on this. So along the way, there are going to be opportunities to spin this technology out into commercial applications. So for example, think of a laser as three parts. There's a master oscillator. That is what creates the ultra-short pulses that we then put through a first stage amplifier, and then we put through a second stage amplifier. Just that first master oscillator is a product by itself. And the first application, it might be the first product that we announce, would be a biomedical imaging laser, using it to image certain skin conditions, for example, to look for abnormalities on the skin.
That doesn't exist in that smaller package.
We believe that it doesn't exist at the price point that we're going to be able to introduce it.
But it does exist.
It does exist, yeah. This is, the use of a laser to diagnose skin cancer is done all the time. But it's done in a more expensive footprint. And there are certain, there's a feature that we don't really talk about and we can't really talk about yet that really differentiates this system versus what is typically available today. Typically, the lasers that you see used for that, they operate at one wavelength. The laser that we're going to be bringing to market for this application is a tunable wavelength. So you can sweep across multiple wavelengths, and with that, you get the ability to detect different types of abnormalities all out of the same laser.
And no one's done that yet?
No, no.
And then you have that additive manufacturing, isn't that 3D printing kind of stuff?
Correct. So this is down the road. This is a totally different color laser. It's a totally different technology, but what it has is it has the potential to significantly accelerate the process of extraction in resin-based systems.
To enhance your system, do you think you may be only using, do you use AI?
We do not use AI, but there is no doubt that an AI will be used to do target prioritization of which drone gets hit first. Where we may end up with AI in our system is how we actually do the targeting of the individual drone. So a lot of the systems right now, they just image and they say, here's drone, here's drone, here's drone. We need to see, here's drone, here's the camera. Here's a different drone, here's the camera. So where AI will show up in our system, it will be in the smart targeting of the camera system versus a region of the drone where we just scan across that whole region. It would be going specifically after the camera itself on the first shot.
Is there a foreseeable near future for a Marine to hold a mobile device in his hand and, target the enemy?
There is,
The guy's about to throw a grenade or something else, is that an application?
so you can't shoot lasers at people, according to the international rules of engagement for how you use a laser. But what we can do is we can build a backpack version of the laser that could be used to take out sensors if you were going to be conducting a raid in a particular location. You know, this is not going to be a high power application, it's not going to be a long range application, but we're about to kick down these doors, there are surveillance cameras, whack the surveillance cameras, and then go into the operation.
Neutralize a motor or an engine?
No. No, so again, the goal is to keep the average power of the system low, and so the anti-materiel effects are relatively limited. That's why we go after the electronics of the system.
But it could screw up the electronics of the vehicle coming towards you.
No, most of them are buried under lots of metal.
Right.
Chris, where could ultra-short pulse be used, or is there an application for what people are talking about, Golden Dome?
So, Golden Dome, it's going to be the topic du jour for months and months, I'm afraid. So we're basically rehashing Star Wars from the Reagan years, you know, put interceptors everywhere. I do believe that an entire pillar of a Golden Dome solution is going to be counter-EO. You have to be able to take out the eyes of the things that are looking at you. And we believe the ultra-short pulse laser is the only way to do it because of the small form factor. If you use a continuous wave laser like the 10,000 watt laser we saw before, it just comes down to the fact that it's too big. You can't deploy that anywhere you want. If you want to deploy this system anywhere you want, on any platform you want, ultra-short pulse laser is really the best way to go because you're going to be targeting the sensors, and you want to be able to ensure that there is no countermeasure to those sensors, and really ultra-short pulse laser is the only way to do that. And you can use your imagination about where you could put these things.
What's your financial position? You said you wanted to raise private capital versus the DoD stuff. I assume the DoD is paying you to keep your patents under wraps and some of the other deadlines, but like you said, you don't want to...
They haven't really done a whole lot in that regard. There are certain patents that they don't want us publicizing for sure. So you should think of the company generally as if we were a post-Series A venture type company. So what does a post-Series A company look like? They've generally raised about $30 million. We've raised about $30 million. They're typically 20 to 30 employees. We're about 25 employees. So, but post-Series A does not mean you have a product. Post-Series A means that you have demonstrated a capability and you are now accelerating into production. So that first $30 million has been raised through a pretty tight network of high net worth individuals and family offices. That's where our funding has been. But we live in this middle ground because we're public and because we're OTC, not listed. I can't access the venture markets because they can't invest in public companies. I also can't access Fidelity because we're not listed on NASDAQ. So the high net worth and family office section of the market has been very kind to us. But we also have to get out of the just-in-time financing model. So, you know, when we can demonstrate this capability, when I can do that demo that I was talking about earlier, that is a catalyst for a lot of different paths that we can take.
What are your plans to go to NASDAQ?
So the main thing that we need to have is we need to have the governance processes in place to be able to withstand Sarbanes-Oxley testing. So we are working now on those back office processes. We have the software infrastructure from an ERP perspective and financial system perspective to be able to implement those processes. I've just got to do some hiring on the back office side to be able to implement the processes to make that happen.
Chris, can you talk about the cord integration and how that's going and the timeline for demonstrations? That platform?
Yeah, so again, the cord system is in-house. We are integrating one of our lasers into that cord system, and we expect to be doing demonstrations off the cord system in the battle lab in the first half of this year. And then we expect to take that system with a high-power version of the laser to the field to do outdoor testing by the end of the summer.
Pretty quick, yeah?
It is.
So you're a private company right now, basically.
Quasi-public.
But you're here to show, promoting yourself. So what, for investors now, I'm talking about that category, what is it that you're trying to present to investors?
So number one, I think we're presenting, this is a capability that doesn't exist anywhere else. All of the directed energy contracts, we believe, all of the directed energy contracts that have been awarded for using an ultra-short pulsed laser to deliver an effect on a target downrange on a battlefield, we've won all of those contracts. As we scale the business, we are going to ultimately need capital. So part of this is about educating the market on who we are, what we're trying to do, hopefully showing you that this is a very compelling and interesting investment opportunity that you should be taking a look at.
What do you think how much capital ultimately will it take to bring to market, if you have any range?
So I think that what we have done with the first $30 million is pretty amazing with a very limited technical staff. So it's not hundreds of millions of dollars.
What would be the range to bring it to market where it becomes profitable, in your opinion?
Well, so we can talk about this by what does a typical DoD program look like? So this is a small form factor version of an ultra-short pulse laser, and this is projecting a deployment on a DoD platform called the Joint Light Tactical Vehicle. The DoD expects to have about 40,000 JLTVs in inventory. A lot of those are going to just be moving people around safely. So you're not going to necessarily see a ton of equipment on those. But you will see some of those JLTVs equipped with a full layered stack of short-range air defense capabilities for everything from small drones to helicopters. So if we can get 5% market penetration of that 40,000 JLTV market, that's 2,000 units.
Do you have a projected price for a unit?
We're roughly estimating about $1 million a copy, but that is, that's a projection. So what this shows is how a typical DoD program ramps. So we're probably in year 4-ish right now. The next step is when we get to the prototype, some customers will say, I want to buy 3, I want to take these things out to the field, and I want to use them in a real-world situation and make sure that they're going to deliver the value that I'm expecting before I place an order for 2,000 units. Once that has kind of been validated in the field, you start to see the volumes increase until you get a full rate production. This is projecting roughly 250 systems a year. But again, what I know for sure is the chart's not going to look like this. We don't really know, but this is just to give you a feel for what a typical DoD program could look like and what the opportunity is for just this one application for this one platform.
What would it cost in capital to do that one application?
I can't give you a solid answer on that right now.
Will you have restrictions on overseas sales, even to its friendly countries, let's say England, Canada, whatever, but will you be able to do overseas sales?
We will be able to do overseas sales, but you have to apply for a license for every country that you want to sell to. So even if we want to sell to the UK, we have to apply for an ITAR license to be able to sell to.
Would you be likely to get those to friendly countries?
Yes, yeah, definitely, yeah. So just to wrap up, hopefully we answered the questions. I will open it up now. Thank you for the engagement during the presentation. That's kind of refreshing because I hate being in monologue mode. It's much better when I get to engage with the audience and you're asking questions. How much time do we have left?
You're way over.
Oh, we're way over. No. All right, so I didn't get through this very quickly. Can you put the presentation back on? I'd just like to end with what I view as a representative image of what we're trying to do, and that is, I told you we intend for the lasers that we build to show up on any platform you want, including the Austin Powers use case, sharks with frickin' lasers on their heads.